soap detergent. Let's look on to triglyceride. What is triglyceride? All the animal fat or vegetable oil, they are an ester which known as triglyceride. What is triglyceride? They make of three parts. You look onto the corner of the picture. They make of a glycerol, and three fatty acids. And now let's look. And the fatty acid, which is a non-polar hydrocarbon chain, a non-polar hydrocarbon chain. Glycerol is made of a CO and H, which is a polar group. They are a polar molecule. And what linked this non-polar fatty acid and the glycerol together? They linking by a bond, and this COO bond, which we learned earlier, the ester bond. So triglycerol have a polar glycerol part and a non-polar fatty acid part, and they linked together through the ester bonding, COO ester bond. Sulfonification, that is about soap making. The rule is all the fat with strong base NaOH, it forms soap and glycerol. This looks very much like your early topic. If you look, the glycerol is an alcohol, OH. Fatty acid is a COOH. On your ester topic, acid and alcohol through concentrate sulfuric acid, it forms into a ester bonding. So this is the triglyceride. And triglyceride, what we're doing is reversing ester. We're using a strong base. We're using a strong base to reverse it back. So, of course, so does it reverse back into fatty acid? Very light, but not a fatty acid, but rather you have, instead of H, you have a N8. So you can see this is very of a reversing of an ester by using strong base. Now let's look onto the experiment. You have a pot, you put some oil with NaOH. So you have the oil, can be any type of oil. You can get from any cooking oil and mix with a NaOH. You mix it together, you turn up the heat, you stir it up slowly under the heat, then slowly they will dissolve each other and you don't see it anymore. It becomes clear, it becomes mixed. Then you let it cool down, and now this is the soapy water. This is forming the soapy water. Now you're adding a spoon of salt. Once you add salt, you will start to see precipitation. This precipitation is the precipitation of soap. Then you use a filter funnel to filter it out, and you get the soap. This is the experiment. And what about soap and glycerol? The glycerol will remain in the soap, and glycerol is very good for the skin. And this day, when in the soap making process, they always separate the glycerol and sell it for the pharmaceutical, as you can use it for many use. For example, as for toiletry or cosmetic and many other use. So it is more profitable to separate the glycerol from soap and sell it separately. Now let's look on to the molecular action of soap. You look onto the soap. Soap have two parts. The head is a negative polar part. The tail is a non-polar part. As you see, you have a COO, which is the negative head, and with a CH2 hydrocarbon tail, that is non-polar. The COO part called the carboxylate group. This group, they are polar, so they form hydrogen bond with water. The tail part, which is a hydrocarbon chain, they can form disperse force with oil. So, oil and water through this soap, it can mix. As if you look onto the soap, the tail part will stick to the oil. The head part will stick out to the water. As the COO part, they are polar, they facing the water. The hydrocarbon tail will sticking to the oil. And now they form into a small droplet. This is called meso. Now let's see the action. If you have some oil and grease, and you put some soap, which the red dot represent the COO, the tail, which is the hydrocarbon tail. Now you see the action. Now they can grab the oil and form into a small droplet. So, soap molecule, it helps to emulsify the grease to make it into a small droplet, which can mix with water and be washed away. So, it helps to emulsify the grease, make it into small droplet, so you can mix with water and be washed away. If oil and water, you mix it together by shaking, the oil droplet will disperse evenly in water, but after a short while, they separate. Oil layer float on the top, water layer sink at the bottom, because oil and water do not mix, as in this picture. However, if oil and water, you add detergent and mix it together by shaking, oil and water will mix and remain dispersed evenly in water for a long time. This mixture we call emulsion, and soap acts as an emulsifier. If you look onto the molecule of this emulsion, there is many tiny little droplets of miso, which is the oil and water mixture, and with the soap act as an emulsifier to form into this tiny droplet. These tiny droplets, they deflect light, which make it look milky, instead of on the corner of the picture, oil and water, which is clear. And the emulsion, it look milky because the tiny droplet of miso deflecting light. Now we go back to our early topic, underground water, which contain calcium, magnesium. We call hard water because of this calcium. Soap is in hard water, they don't work well. They do not form leather, but rather they form into this greasy floating precipitate we call scum. And in 1940 year, detergent was introduced because of this reason, and it largely replacing soap as a cleaning agent. Now if we look onto the structure between detergent and soap. Detergent, it looks very much like soap. It also have a polar part and a non-polar part. As the polar part, this SO3, it is negative charge and is polar with a long hydrocarbon tail. So you have a CO3 minus polar group. Compared to soap, you have a COO, also negative, which is also polar and with the same non-polar tail. So in nature, they are much the same. The advantage is this detergent does not form insoluble precipitate with calcium or magnesium, so it does not form scum. So take notice, detergent is a SO3 minus, soap is a COO minus, and this is the main difference. As you see, CO3 and SO4, they are medium soluble as add in detergent. But when calcium with carbonate, like soap COO, they are even less soluble, which more easy to precipitate as scum. There is many different types of detergent nowadays. They have the negative charge detergent, the positive charge detergent, and the polar detergent. The negative charge detergent is the one we just mentioned, called the anionic, negative charge. Anionic detergent, this detergent is the most common use. We use it for laundry detergent, dishwashing liquid, or hand wash soap, or even toothpaste. the positive detergent, cationic detergent, it is used as a fabric softener and hair conditioner. As in most clothing material, when they wet, they slightly negative charge. What's meant by that? If you look onto hair or wool fabric, after wash, they are slightly negative charge on the side. So, if you put after wash, if you put hair conditioner or fabric softener, basically you put that a layer of positive polar tail. So you're putting a positive polar tail onto the fabric. So you're coating it with a positive oil. So this waxy coating, it helps to reduce the static and tangling and make it feel much softer. That's why after you washing hair, you always will add some hair conditioner. Same as you washing clothes, you using fabric softener to make it less, to reduce static and tangling. Non-ionic detergent, they are not positive or negative, but rather they are polar, which with both positive and negative. So this polar detergent, they have one good advantage. They do not form so much foam. So when you stir them up, they don't form so much foam, which good for using for the dishwashing and the washing machine.